Right, this is a tricky question, but it only uses one equation um, over several steps, which is what makes it tricky. The equation that it uses is Hooke's law, F equals kx, um, with the triangle here, if that helps. I'm not going to put the calculation steps in because there's too much to show. I'm just going to put the sort of the outcome of each calculation. Right, so the first thing is we have this mass of 34.28 newtons, and I'm going to put one down here as well. And then there are two situations. The first is where there's one spring supporting that mass, and then the second situation is shown in the diagram. So we have the 80 Newton per centimeter spring in both of those situations, and then there's an extra spring which we don't know the spring constant for. So where do we start? Well, if we know two things, we can work out the third. So the first place that we start is with these two, and they tell us that the extension when the spring was on its own is 0.4285 centimeters. The question also says that once the two springs are connected, the mass rises by 0.2. So that then tells us that the new extension on the right-hand side here for both of these springs is 0.2285. The next thing I can do is, looking at the left-hand side here, I have the spring constant and the extension, so I can work out the force from this single spring, which is 18.28 newtons. And because that's providing some of the upward force, I can calculate what remains, and therefore what must have been provided by the other spring. So I use the difference here to tell me that the right-hand spring must have been providing 16 newtons upwards. Now, because the two springs have the same extension, this extension here applies to both of these springs. I can then work out the final spring constant, which is going to be 70.